we talked about linear functions yesterday. You remember for a function or for a set of data points to be considered representable by a linear function, it needs to have constant slope. Remember, the slope wasn't changing between the data points we were looking at. And you remember the form f of x equals mx plus b, or b is your y-intercept. The m on the mx, that's the slope, that's the rate of change, the average rate of change. We talked about that yesterday. And so it's how much is the y value changing compared to the x value. So if the average rate of change of a function is a constant m, a linear function f can be used to model the relationship between the two variables as follows. Now, your variables may change. You may have f of t, f of j, whatever, but in this case, we're talking about f of x, and it's going to be mx plus b, where b is the value of f at 0, that is, b is equal to f of 0, which we talked about. I mean, it's the y-intercept, so it's when x is 0 or when the other variable is 0. So one of the things that we can use linear functions to model is straight line depreciation. And straight line depreciation is an accounting method of calculating the value of an item. Book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate assets using straight line depreciation so that the value of the asset declines by a fixed amount each year. So like you work for a company that has a printer, and you buy a printer for $20,000, and you go, well, this printer is going to last us 5 years. Not 5 years, let's say 10 years, right? And so after 10 years, it's going to be worth nothing to us. And so each year we reduce the value of that printer until it's 0 on the 10th year. That's basically what it does. The amount of the decline depends on the useful life that company assigns to the asset. So if you made our printer only last us 2 years, then it's going to depreciate. It's going to decline more rapidly, more per year, than if we make it last for 10 years. Excuse me. Suppose a company just purchased a fleet of new cars for its sales force at a cost of $31,500 per car. The company chooses to depreciate each vehicle using a straight line method over 7 years. So what that means is that when you initially buy the car, year 0, it's worth $31,500. Then in year 7, it's going to be worth $0. And we want to be able to model how that's happening, so that way we can say, well, how much is it going to be worth on this year? Or how much is it going to be worth this year? Or in what year is it going to be worth this amount? Okay. And so the first thing we need to figure out is how much is it going to decrease each year? And so if it's decreasing a total of 31,500 over the course of 7 years, and we do that division, 500 divided by 7, and you'll get that the rate of change is $4,500 or $4,500 per year. Any questions on that? So if we want to write this as a linear function, I think part A says write a linear function that expresses the book value V of each car as a function of its age, X, in years. How would you write that? Or we want V of X is equal to mx plus b. And so what we need to figure out is what is m and what is b. So what do y'all think I think the easiest one to start with is what is B? What is B going to be? Anybody know? $31,500. Good. And we know that because that's the price of the vehicle at 0 years. So your initial value, your starting value, is going to be $31,500. So that is going to be your y-intercept. That is going to be B. Any questions on that? All right, the hard question. What is M going to be? What is the rate of change that's happening per year? It's 4,500x. You're very close. Very close. Well, what are we doing? Well, let's not include the x in there. Let's just do 4,500. But is it increasing by 4,500 or is it decreasing by 4,500? It's going to be decreasing by 4,500, right? And so we need to make that M negative. So that way it's a negative slope. That way it's decreasing. Remember we talking about increasing, decreasing constant functions, linear functions? We want this to be a decreasing function. So we want to make our slope negative. So our function is going to be v of x is equal to negative 4,500x plus 31,500. Any questions on that? To graph it, I mean, it's not super tough to graph it. I think I got a little graph for it somewhere set up. Yeah, I did. Thought I put one. Well, maybe not. Well, remember, you just need 2 points to graph it, right? And so what we can do is have our vertical axis. That's going to be the value of the car. And when we first start, the value of the car is what? It's 31,500. And then we'll have 1, 2, 3, 4, 5, 6, 7. And 7 years down the line, it should be worth nothing. And so our graph is going to look like that. That's basically all there is. You could choose some other points too. If I get in some x values, getting some y values. Hey, you can do that if you want, but we just need 2 points. We have 2 easy points. Do that. Let's see. What is the book value of the car after 3 years? So if we want to know the book value of the car after 3 years, we're going to try to find v of 3, which would be negative 4,500 times 3 plus 31,500, which is going to be negative 13,500 plus 31,500. Which would be $18,000. So after 3 years, it's going to be worth $18,000. Any questions on that? D, interpret the slope. I think you understand that every year it's going to decrease by $4,500. Part E, when will the book value of each car be 9,000? So if you want to figure out what year is it going to be worth $9,000, we're going to set this up. Instead of v of x, we're going to say, well, 9,000 is equal to negative 4,500x plus 31,500. And then we're going to solve that linear equation. We're going to subtract 31,500 from both sides. Oop. That is 900. We get 22,500 is equal to negative 4,500x. And we're going to divide both sides by negative 4,500. And so, oh, this was a negative here. What we get is x is equal to 5. So after 5 years, the vehicle, well, each vehicle would be worth $9,000, which makes sense because there's 2 more years left. So if you take 9,000, you take away 4,500, you're left with 4,500. Take away another 4,500, and you're at 0. So you can kind of check your answer for these with that. Any questions on that one? All right. Nope. Guess I just have room for that. Another thing that we can use linear functions to model is supply and demand. Now, if you go into business, for a business degree, you're going to see this more, supply and demand, 106 for sure. But if you recall how supply and demand works, it's about the price of the product and the quantity of the product and the relationship between the two for how much is supplied versus how much is demanded. How many does the company want to produce versus how many does the public want to buy? The quantity supplied of a good is the amount of product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of product that consumers are willing to purchase at a given price. So if you make a TV and it's, normally $200, if you start charging $500, yeah, the company wants to produce more so that people would want to purchase less. If the TV is now $100, so it's cheaper, more people are going to want to buy it, so the demand is higher, but the company that produces it will not want to produce more because they're not making as much money. That is how supply and demand works. Suppose that the quantity supplied S and the quantity demanded D of widgets are given by the following function. And widgets is just a random term that they use to describe situations without using an actual term, an actual product. And so when you have this S of P is equal to 40P minus 200 for the supply, and D of P is equal to negative 20P plus 1,000 for the demand, what those equations or functions is giving you is Q, the quantity. It's just like how we had f of x and we said f of x was the same thing as y. Here, S of P and D of P is the same thing as Q, the quantity. It's just the quantity supplied and the quantity demanded. The P is the price, how much is going to be charged for these items. And it looks like in this case it's in dollars. Sometimes they'll do it in like hundreds of dollars, thousands of dollars, and you have to pay attention to that in the problem. But this one is just dollars. Make it a little bit easier. Okay, so what you have is just two linear functions, right? You got this first linear function for supply. It has positive slope. So you got 40p, 40 would be your slope. The negative 200, that would be your y-intercept. Or I guess in this case, the q-intercept, right? For D of P, you have a slope of negative 20. And you'd have a q-intercept, or let's just call it the intercept, of 1,000. Okay. So if the price was 0, the supply would be negative 200, which doesn't really make sense, but that's just part of the model. If the price was 0, the demand would be 1,000. You can think of it that way. Now, the thing that people like to figure out from supply and demand is what is the equilibrium price? What is the price I need to charge so that the supply quantity and the demand quantity are the same? They're equal, equilibrium. And then from that, we can find what is that quantity? What is the quantity that's going to want to be supplied and demanded, because it's going to be the same quantity because it's equal, when the price is that equilibrium price. And so what that gives us is what's called the equilibrium price, the equilibrium point, and those combined, I might have just said it actually, is the equilibrium point. That would be the equilibrium price, comma, equilibrium quantity. So it's a point. That would be the equilibrium point. Oh, they said it in part C. I just noticed that. So the equilibrium point is where those two will intersect each other, and that will give you the equilibrium price as well as the equilibrium quantity. Any questions on that? Nope. So if we're looking at these two, we have S of P is equal to 40P minus 200, and D of P is equal to negative 200P plus 1,000. Now, there's different ways to solve this. You could actually go back to what we did for a system of linear equations. But since we're trying to figure out where are the two things equal to each other, where are the two quantities equal to each other, and they're both already solved for Q, what we can do is just take them and set them equal to each other. We can just say, well, we want to figure out where does S of P equal D of P. And so if we write out what their actual functions are, it would be 40P minus 200 is equal to negative 20P plus 1,000. We only have one variable there, and that is the price, and so we just need to solve for that variable. And let's say we add 20P to both sides. And so we'll have 60P minus 200 is equal to 1,000. And we'll add 200 to both sides. So we'll have, let's come over here, 60P is equal to 1,200 divided by 60. And P would equal what? 20. So what that means is that the quantity supplied and demanded are equal when we charge $20. So we charge $20 for whatever we are charging for. The quantity supplied and the quantity demanded will be equal. Now, to figure out what that quantity is, all we need to do is take that 20 and plug it in for one of the P's. It does not matter which one we use because the quantity should be the same for the supply and the demand. So if we plug that in, let's do S. We do S of 20. That'll be 40 times 20 minus 200. It's going to be 800 minus 200, which should be 600. So the quantity supplied and the quantity demanded should be 600. Let's test it out. Let's do it with the demand function as well. So the demand of 20 would be negative 20 times 20 plus 1,000. And that's going to be negative 400 plus 1,000, which is also 600. So the equilibrium price, $20. The equilibrium quantity, 600. The equilibrium point, 20, 600. Any questions on that so far? Nope. Okay. Well, if we want to graph it, got a graph right here. Now, let's do demand in blue and supply in red. That way we can tell the difference. Now, the one thing that we know is that they're going to intersect each other when P is 20 and Q is 600. So if I go look here, P is 20 right here, Q is 600 right here. So I know I'm going to have a shared point right here. So that's the one thing I know so far. Next thing I know, let's try to graph the demand function. Well, the demand function's y-intercept is 1,000, or q-intercept, right? Its zero value is 1,000. You put a 0 for P, you get 1,000 for Q. And so we know we're going to have a point up here for our demand. And so if we draw a line between those two, get something like that. That's our demand function. I'll label it. The supply function, not as easy, because my y-intercept there is negative 200. I don't have that on my graph. So we could plug in a P value and see if we get a good Q value. Now, the one thing I see is if we plug in a P of 5, if I do S of 5, do I have 5 on there? 1, 2, 3, 4. It might be kind of tough. Let's try S of 10. Let's see what we get. So use your graph to kind of dictate what you can use. And so we'll have 400. Sorry, I'm doing the math in my head for me right now. 40 times 10 minus 200. So that's going to be 400 minus 200, which will be 200. So I know I have the point 10 comma 200 for my supply function. And so if we go to our graph, P is 10, Q is 200. I know I'm going to have a point right there. And so we connect those lines there and continue it this way. That's going to be a graph of my supply and demand functions. The point where they intersect, that is the equilibrium point. It's got the equilibrium price, $20, and the equilibrium quantity, 600. Any questions on that one? No? Good. All right. So now got a few problems for y'all to try, and we'll go. So first one, we got a truck rental company rents a moving truck for 1 day by charging $36 plus $0.06 or 6 cents per mile. Write a linear equation that relates the cost C in dollars of renting a truck to the number of X miles driven. And then we want to figure out what is the cost of the truck, of renting a truck, if the truck is driven 200 miles or 342 miles. So we'll give you a moment. We're down out, and then we will go. All right. So we just got to determine what is changing and what is constant. And so when we read this, and it says that the price relates the cost of renting a truck to the number of X miles driven, and we see that they give us that it's 6 cents per mile, that tells me that my slope is going to be that 0.06. That's how much is changing per mile that you drive. And it's increasing, so I know it's going to be positive. The other thing is that if you rent it for a single day, there's an initial cost, just a straight cost of $36. And so that means that even if I don't drive any miles, I'm still going to pay $36 to rent this truck. And so that will be our intercept. That will be our B. And so the cost function is going to be C of X is equal to 0.06X plus 36. That'll be our cost function. Any questions on that? All right. Now, if we want to know the cost of renting the truck if it is driven 200 miles, well, it's going to do C of 200. Should be 0.06 times 200. Try to write that a little better. Plus 36. And that'll be what? 12 plus 36, so 48. So it'll be $48 to rent that truck for a day and drive it 200 miles. And then if we want to know how much it's going to cost to drive 342 miles, well, same thing, except we do C 342. So the 0.06 times 342 plus 36, which is going to be $20.52 for the mileage plus the 36. Would be $56.52. And if you want to round to the nearest dollar, it'd be $57. Any questions on that? All right. We kind of did these yesterday. Let's try to find it better. Let's do a couple. One. So here they give us a linear function, and what we want to do is determine the slope and the y-intercept, determine the average rate of change, determine whether the linear function is increasing, decreasing, or constant. So those are the three that we're trying to find. And you want to graph it. I think that's the second step. Let's just move these over here so you can see them all. So determine the slope and the y-intercept, graph it, and then we'll determine the average rate of change and whether it is increasing, decreasing. All right. So, kind of like what we did before on another problem, we want to find the slope, find the y-intercept. We're going to use that to graph it. So the slope is going to be the value, the coefficient on the x, which is going to be 5 in this case. The intercept is going to be that constant there, which is 2. And so to graph it, we're going to use that. We know that when x is 0, y is 2. That gives us this point here. And then with a slope of 5, that means that it increases 5 vertically and goes 1 to the right horizontally. So if I go up 5, 1, 2, 3, 4, 5, and then over 1, this will be my line. You could also go down 5, 1, 2, 3, 4, 5. I think I drew my line a little funky. 1, 2, 3, 4, 5, and over 1. So there should have been a point right here too. Let's clean that up. 1, 2, 3, 4, 5. And we can go down, let's say 1, 2, 3, 4, 5. Checks out, and 1 there. So all 3 of those should go. There we go. Any questions on that part? See, we want to know the average rate of change. Hey, that is the slope. Boom. And then we want to determine whether the linear function is increasing, decreasing, or constant. Anybody knows what it is? Increasing. Yep, we know that because the slope is a positive number. So this is an increasing linear function. Good. If it was negative, it'd be decreasing. If it was 0, it would be constant. All right. Let's see what else I got. Let's see those. Yeah. Let's do this one. So same thing, just a little bit different function here. Find me the slope, y-intercept, graph it, talk about the average rate of change, and then we'll say if it's increasing, decreasing, or constant. So I'll give you. All right, so first part, we want to know what is the slope. It's just going to be the 1/4. The y-intercept is going to be -6. Notice that the sign comes along with it. It's -6, that's going to be -6. So that means that to graph it, we'll do this y-intercept here of -6. Now that slope means that it goes up 1 for the y and over to the right 4. So 1, 2, 3, 4. So we're going to have a point right here. You could also go down 1 for the y and to the left 4. 1, 2, 3, 4. Get another point. But this is going to be our line. The average rate of change, once again, 1/4. Y changes 1, x changes 4. And to determine whether the function is increasing, decreasing, or constant, it's a positive slope. So this one is also increasing. Now, it is increasing at a much slower rate than the other one. If you recall, the other one was something like this, huh? That was the other line. But it's still increasing. So even though it's increasing at a slower rate, because its slope is smaller, it's still positive, so it's still increasing. Any questions on that? And one more like this. So here we have the function f of x is equal to 2. Give me the slope, y-intercept, graph it, average rate of change, and then if it's increasing, decreasing, or constant. I'll give this one a try. So this one's a little bit different, right? It's just f of x is equal to 2. So we don't have that x term there. And so the slope of this one, anybody knows what the slope of this one is? Oh, remember this is the same thing as 0x plus 2. So the slope here is just 0. And then my y-intercept is going to be at constant, just like before, so just 2. And so since this is just no x in my function, just a number, that means it's going to be a horizontal line, y equals 2, across there. Remember, it can't be a vertical line because it won't be a function. It'll be a line, but we're talking about linear functions here. The average rate of change, hey, it's using 0. And then if we want to know if it's increasing, decreasing, or constant, The slope is 0. That's not positive, so it's not increasing. It's not negative, so it's not decreasing. So this one is constant. Makes sense. The function is just equal to a constant number. Any questions on that? All right. What we got here? I want to choose a good one of these. Let's do this one and that other one. So what you want to do here is try to determine if this function is linear or nonlinear. If it is linear, then we want to determine the slope. Remember, to do this one, we're going to figure out the rate of change or the slope between each of our data points. So you have a y value of negative 28, x value of negative 1, y value of negative 4, x value of 0. So we're going to find the slope or the rate of change between those two. So let's do negative 28 minus a negative 4 over negative 1 minus 0. Remember that the points on top, or the values on top of each other, need to come from the same ordered pair. And so that's going to equal what? Negative 24 over negative 1, which equals 24. So the slope or the rate of change between those first two values is 24. If we do the next one and it's like 3, we know it's not a linear function. Okay. So let's do the next one. Let's change the color so you can figure it out. So we'll do negative 4 minus 3 over 0 minus 1 should be negative 7 over negative 1, which equals 7. And so at that point, we have one that's different. Now we can continue on and see, but as long as the slope changes at some point, it's not linear. So this is going to be non-linear. Any questions on that? Next one we can work out together. What do y'all think of this one? You got x is negative 1, y is 4, x is 0, y is 4, x is 1, y is 4, x is 2, y is 4, and x is 3, y is 4. Will that be linear? Anybody have a guess or an idea? Well, we can do the same thing we just did to test it. I mean, these two, it's going to be 4 minus 4 over 0 minus, so let's do the other order. Let's do negative 1 minus 0, which would be 0 over negative 1, hey, which is 0. You think it's a horizontal line? Yeah, let's work it out. Well, the first part is horizontal, right? You got a slope of 0. That should be a horizontal line. You do this next one, you do 4 minus 4 over 0 minus 1. There again, you get 0. And you can see when you're subtracting in that numerator, it's always going to be 4 minus 4, 4 minus 4, 4 minus 4. It's always going to be 0. So yeah, the slope of all of these is going to be 0. And so this is a horizontal line. It's linear. And honestly, we could tell you the equation of the line, the function. Anybody knows what it is? The first thing is it has a slope of 0, right? Because it's a horizontal line. It's constant, yeah, and that constant is going to be y equals 4. Or if you want to write it as a function, you should probably stick with that notation. F of x is equal to 4. But yeah, that's right. Good. Any questions on that one? No matter what x is, y is 4. I think I'm zoomed in too much. All right. So, one second. I felt like I need to sneeze. I guess not. I don't. All right. So they give us here is the graph of two linear functions. We have f of x and g of x. You can see that this line right here, this is f of x, this is g of x here. And what they want to know for part A, well, what value of x does f of x equal g of x? That's asking where do they intersect each other? Where do they run into each other? And so if we look at this graph, boom, boom, they intersect right here. The x value of that point is the -5. The y value of that point is the 6. And so if we ask for what value of x does f of x equal g of x, that's going to be x is equal to -5. Now, this next part is what usually messes everybody up. They are asking for which values of x is f of x greater than g of x. That is, for which values of x is f of x above g of x, right? It's greater than, it's above it. And so if we look at our lines here, and I'm going to highlight them, because I want to try. The blue one, that's f of x. And this is g of x here. Where is f of x above g of x? Where is f of x greater than g of x? Well, the blue is above it over here, which for those x values stops right here where they intersect, but it's everything to the left of that x value. So which values of x is f of x greater than g of x? Everything to the left where x is less than -5, where they intersect, and we can write that as -infinity to -5 if you want an interval notation. Any questions on that? Good. All right. How much time we got? Let's go ahead and go to these then. Let's do this one and then that one. All right, so here we go. We got supply and demand functions. S&P is -200 plus 40p. Notice that they just switched around the function. Usually we looked at it as 40p minus 200, but they've just switched around. That's not a big deal, right? We want to find the equilibrium price for t-shirts at a concert. We want to find the prices for which quantity demanded is greater than quantity supplied. And then we also want to know what will eventually happen to the price of the t-shirts if the quantity demanded is greater than the quantity supplied. That is what we're trying to figure out. So we're trying to find the equilibrium price. That means we're going to set them equal to each other. Where are they equal? So we're going to say, well, -200 plus 40p equal 1150 minus 50p. Let's add the 50p to both sides. And we'll have -200 plus 90p is equal to 1150. And add 200. So 90p is equal to 1350 divided by 90. And p is going to equal what? 15. So the equilibrium price will be $15. To figure out what the equilibrium quantity needs to be, we're going to plug that into one of them. Let's do S of, nope, not P. I'll do S of 15. let's do S of 15, which will equal negative 200 plus 40 times 15. What's that? Negative 200 plus 40 times 15. 400. So my equilibrium quantity, which I forgot to put that part, that is part of the question in the homework, is 400. So it's going to be $400. Oh, sorry, it's going to be $15 where the two quantities are equal. And what's that quantity going to be? 400. So it should be 400 items, t-shirts will be supplied and also demanded. All right, we want to determine the prices for which the quantity demanded is greater than the quantity supplied. Now notice that the supply is decreasing, increasing, and it starts at a negative number, and that the demand starts at a high number and then decreases, because as the price increases, the demand will go down. So the demand line is going to be above the supply line until they reach that equilibrium point. And so where is the price? Well, determine the price for which the quantity demanded is greater than the quantity supplied. It's going to be from 0 up into my equilibrium price. So it's going to be from 0 to $15. Notice I included 0 because if the price is $0, people will probably demand it more than I want to supply. But I don't include the 15 because at 15 they are equal. So this is going to be the answer to that question. Any questions on that? And then this last one's kind of a critical thinking thing. What will eventually happen to the price of the t-shirts if the quantity demanded is greater than the quantity supplied? So if the quantity demanded is greater than the quantity supplied, so people are demanding it more than what they are able to supply it, what are they going to do? They're going to increase the price. So what will happen if the price of t-shirts, if the quantity demanded is greater than the quantity supplied? It's just going to increase the price. No worries, Harley. We're about to finish anyways. I just got one more problem, and we're going to work that one together. Any questions on that one? All right. Where was my last one? There it is. All right. So another thing that we can look at that is similar to what we were just talking about with the equilibrium price and equilibrium quantity and where are they equal to, that's the equilibrium point, is what we call a break-even point, okay? When you have a business, you have your cost, you have your revenue. Revenue is how much money you're bringing in. Cost is how much money you're spending. And so notice that we're not talking about profit at all, because profit is the actual thing of this. If you take your revenue minus your cost, that's your profit, right? So what we want to figure out is for what number of items that we produce and sell each day will our revenue equal our costs? Will our amount of money bringing in break even with the amount of money we're spending? And so what we're going to do is take R of X and set it equal to C of X. And so, like we did before, take 100x equals 65.5x plus 69,000. Let's subtract 65.5x from both sides. That's going to give us what? Yep. 34.5x equals 69,000. And we'll divide by 34.5 on both sides. And we'll get 2,000. So when we produce and sell 2,000 items, that's when our revenue is going to equal our cost. That's when we're going to break even. Now, they want us to find the values of x such that r of x is greater than c of x. Now, we could graph these like we did for the other ones and figure it out. We could say, well, you can see that the revenue is just 100x. It starts at 0, and it's going to grow. And you can see that the cost is what? Well, that starts at 69, and it grows as well. It just grows at a less rate. Or, instead of trying to figure it out that way, we can just set it up. We know how to solve inequalities. So if we set up r of x is greater than c of x, we're going to say what? 100. Is it 100x? Yeah, okay. Thought I messed up. 100x is greater than 65.5x plus 69,000. Let me fix that. And we're going to solve that basically the same way. Subtract 65.5x from both sides. We get 34.5x is greater than 69,000. Divided by 34.5. And we'll get x is greater than 2,000. So for what values of x such that r of x is greater than c of x, we want to represent the number of units the company must sell to earn a profit. That means that the company needs to produce and sell more than 2,000 units to make a profit. If we make and sell 2,000 units, we're breaking even. If we make and sell less than 2,000 units, we're losing money. We're going to be in the what they call the red, right? Our costs are going to be higher than our revenue. And so we want to make and sell greater than 2,000 items to make a profit.